Okay, for this lesson we're going to look at some linear equations worded problems and also in particular some problems that involve simultaneous equations. So in our first example we've got a question where we have four consecutive even numbers are added and the result is doubled and divided by 11 and the number 24 is obtained. We want to find each of the numbers. Now you can see that what I've done here is I don't know what the first number is, so I'm going to call that x. And given that I know that we have consecutive even numbers, the next number will have to be 2 more than that. So the second number will be x plus 2, and likewise the third number will be x plus 4, and the fourth number will be x plus 6. Now if we look back at the question, it says when the four consecutive even numbers are added, so I'm going to add them up. So I have the 4 x's and the numbers add to 12. So that sum is 4x plus 12. Okay, what I'm then going to do is look at the next part of the question, which says the result is doubled. So I put my 4x plus 12 in brackets and I double it, putting a 2 out the front. And the other thing that was done, it was then divided by 11. So I put the whole thing over 11. And the resulting number, or the number that's obtained, is 24. That's telling us that it's equal to 24. So now I've got my expression. I could use the CAS calculator to solve that now by using advanced interactive solve, or I could do it by hand. If I do it by hand, I'd probably multiply those brackets out first. Remember, brackets usually come first. So I have 2 times 4x is 8x. I've got 2 12s are 24. And when you have a fraction that equals a number, this is 24, and we times that by 11 to get 264. So 8x plus 24 is 264. I'm then going to take the 24 to the other side of the equation, taking it away from 264. That leaves me with 240. So 8x is 240. Last step is to divide both sides by 8. So x is 30. Now at this point we look back at the original question to think, well, what the hell was x? And we say, okay, well that was the first number. So that gives us our bearings now for working out the other numbers. So we have 30 as our first number. The next one, remember, was x plus 2, so that's 32. X plus 4, so 34, and then 36. In the second problem, this is really one that we would do as a simultaneous equation. We've got, we're told the current total of John and James' age is 100. Now, of course, we don't know what their ages are, so straight away we're going to need two variables. So in 10 years' time, James' age will be double that of John. What are their current ages? Alright, let's just go back to the original part of the question. The current total of their ages is 100. We don't know what their ages are, so we're going to let John's age equal x, and we'll let James' age equal y. So our first equation is that their ages add up to 100 at the moment. So x plus y is 100. Okay, what about in 10 years' time? Well, in 10 years' time, John's age won't be x anymore. It'll be 10 years older than x. So in 10 years, John's age is x plus 10, and likewise James's age will be y plus 10. Now, this next bit refers to the fact that in the 10 years' time, James's age is double that of John. Alright, so what we need to write here is that James's age in 10 years' time, so that's y plus 10, is double, so 2 times John's age in 10 years' time. Alright, so we've got y plus 10 is 2 times bracket x plus 10. We've got our two equations there. We could use the 2D tab on the class pad and solve simultaneously, and that would be fine. If we're going to do it by hand though, we might take equation 1 and just rearrange it a little bit. So up here, looking at equation 1, we could make an expression for y by taking x, this x, to the right hand side of the equation, so it's over there with the 100, and we'd have y is 100 minus x. Okay, so now what we could do is, wherever we see a y in our second equation here, so at the front there, wherever we see a y, we can replace that with 100 minus x. So that's what I'm going to do. I've said sub this in equation 2. So equation 2 now, instead of a y, I've got 100 minus x, still got the plus 10, equals 2 times x plus 10. I'm going to simplify the left side because 100 plus 10 is 110. Still got the minus x there. On the right hand side of the equation I'm going to expand our brackets. 2 times x is 2x, 2 times 10 is 20. Don't forget to do the second one. Don't just write a 10, it's 2 times 10. Okay, now I want to get all the x's on one side of the equation and the numbers on the other side. I notice that on the left that's a negative x, and on the right we've got positive 2x. Geez, I like positive numbers, don't like working with negatives, so I'm going to take the negative x to the right hand side of the equation as shown by that arrow, and that means this 20 is going to have to come over to the left and be a negative 20 over here. So now I can collect my numbers. 110 minus 20, that's going to give me 90, and the 2x and the 1x give us 3x. 3x is 90, last step is always divide. Dividing both sides by 3, x must be 30. Referring back to the question, who was x again? Well, back up here, that was John's age. So now we know that John's 30, and using our first equation we know their ages add up to 100 initially, and x is their initial age. So John's 30, James must be 70.